Hello everyone. We are Group 8 for Multivariable Calculus Section 4. We are going to present about our project results. My name is Tong Kim Yao, metric number AE230070. Question 1. We need to find the area of region by the given two curves, y equal to x squared and y equal to 2x. Firstly, we draw the curve for y equal to x squared, and then draw the curve for y equal to 2x. Lastly, we combine the two curves to get the bounded area. Next, we need to find the area of the region. Since both curves have the intersection point, so we can use this equation to get the value of x equal to 2 and y equal to 4. By using the vertical strip technique, we can get the interval for the dx and dy, and we apply it into the formula. We will get the area of the region is 4/3 units squared. Next, I will use the method software to perform the simulation. Firstly, we need to define the f and g as the given curves. After that, we need to combine both of the curves to get the bounded region. We can plot the 2D graph to get the bounded region. So this is the bounded region. Find the bounded region area. We need to use the y equal to x squared to minus the y equal to 2x. After that, we just need to solve this equation, and we will get the interval for the x. Finally, after we get the interval, we need to plug it into the formula to get the area of the region, which is equal to 4/3. That's all from me. I will pass the presentation to the next presenter.
Hi, it's Nimanjan. My metric number is AE230060. Today I will going to present about the method calculations and the simulation using MATLAB to solve the multivariables calculus project. Question 1b, finding the surface area of the solid. The question given a paraboloid questions z equals to x squared plus y squared, and it wants us to find the surface area of the paraboloid in between z equal to 16 and z equal to 4. We can use this to find 3 points to help us to sketch a 3D graph of paraboloid so that we can determine which projection we want to use. After we finding the 3 points, we know you stop at 16 and the region will stop at 4. From 4 to 16. From top, we look at from below. We take xy projection. If we look like this, the area we want to find is here. And based on this, we can use polar coordinate called it circle. The interval we use is dr 2 to 4, d theta is 2 to pi. Because we use x projection, the f will be equal to z, and therefore we can find fx, fy, and fz. Fx is 2x, fy is 2y, fz is 1, and the area formula is double integral fx squared plus fy squared plus 1 square root whole times r dr d theta. And we sub the correct interval, and we can sub the value of fx, fy, fz into these equations, and then we factorize the 4 become x squared plus y squared, and sub r into the x squared plus y squared, where x squared plus y squared is equal to r squared, and then we can solve. Use calculator, or from here we can use calculator, or we use substitution to get 33.83. After we can use calculator again, find the final value is 237.69 units squared. This is area. Now I will proceed into a mapper to prove our working. First, I will type these equations to comment the mapper to know this equation we want to use, and we want to verify our 3D whether it's correct or not. We select all, double click, press all, pop 3D XYZ. It will appear like this. It will verify our 3D shape sketch is correct. Then we use expressions, and I let the software know my equations will be these terms. And then I use substitution by typing this. Result is the function I want to use for this. When z equals to 4, sub into these equations. And we can see the plane by highlight all and double click, and and select plot 2D plot XYZ, it will appear a circle like this. And the Z, when Z equals 16, also same. Like this, and it will appear equations, and then we select it and plot 2D XYZ, it will appear a circle with radius of 4. You want to find the intersections, we type this result 1 and result 2. It will appear two equations, then we select it and plot 2D XYZ, it will appear an intersection 1, and the inside one is the area we want to find. From this, from 5, we can know our interval is 2 to 4 and d theta is 0 to 2 pi. And the f functions, I let the f function equals to equation. So this is f functions, and then we do the partial integration by typing this code. It appear from 7, we know fx is 2x, fy is 2y, and fz is 1. And then we do the fx squared plus fy squared plus fz squared. It will appear 4x squared plus 4y squared plus 5. And I let g function equal to these equations, and then I factorize out 4 and sub r squared into x squared plus y squared, and I let g function become these equations. And then we can find the surface area by using this and type correct interval. We correct differentiations, and then we can press this is the answer, or we can know the numerical answer. We press this, double click and solve. Numerical solve, it will appear the area if verify our answer is correct. That's all for me. Thank you.
Hello everyone, my name is Samuel Kai. My matrix number is AE230076. Now I will present about the question 1C for our project. And this question is about use double integral to determine the volume of the z equals to square root 4 minus x squared minus y squared. First step, we will, from this equation, we will simplify this equation. We will get the sphere equation, and we can draw this one based on this sphere equation. And from this 3D diagram, we will get the xy projection. And from the xy projection, we can get the interval. The dr is 0 to 2, the d theta is 0 to 2 pi. And the function is equal to z equals to square root 4 minus x squared minus y squared. And from this information, we can get the volume of this sphere. This one we will use the U substitution to solve this problem. We will get the 8 over 3, and the final answer we will get 16 over 3 pi unit cube. Now I will use mapper to prove our manual calculation is true. It's question 1C. And then first we will write down the z function. Our z function is equals to square root. Then we enter, we will get this function. Oh, this one is negative. And then we will write the equation, the sphere of the equation. Oh, the enter. We get this sphere equation. And this, when we highlight this, and we can plot the 3D diagram graph. For this, we can see that this one is the sphere of the 3D diagram graph. From this diagram, 3D diagram, we can get the xy projection. The xy projection is, first the z is equal to 0. From this diagram, we can get the z is equal to 0. And then we sub the z equal to 0 to the sphere equation. And copy this sphere equation to here. And then we enter, we'll get the circle equation. And this circle equation, we can plot the 2D graph. And this one is a 2D graph. And from this 2D graph, we can get the interval. And this interval is to calculate the volume. First, we will proceed to the dr. The dr is 0 to 2 from this 2D diagram. And then the d theta. The d theta is from this 2D diagram is 0 to 2 pi. And then we proceed to the function. And then press enter, we will get this function. Now we will continue to the function. And we will subs the x squared plus y squared equals to r squared into this function. You get this function. After we subs the x squared plus y squared equals to r squared, we will get this square root negative r squared plus 4. And then now I will can do the volume. We can solve the volume. And from this, we highlight this one. We can solve it for the variable. And we press the solve, we will get the volume is 16.3 pi. Therefore, it is same with the result of the manual calculation. That's all from me. Thank you.
Hello, my name is Muhammad bin Sabubari, laboratory DE230123. Now we continue the presentation for question 2A, triple integral application. We need to find the volume of solid in the first octal bounded by plane x plus y equal to 4 and xy plane and the surface z equal to x squared plus 6. The bounded for x, y and z are x goes for 0 to 4, y 0 to 4 minus x, z 0 to x squared plus 6. Okay, using the triple integral, we calculate like this. After solving step by step, the total volume is 69.33 cube unit. Okay, let's continue the presentation for simulation question 2A. First, declare the command for imagine the diagram of the question like this. And secondly, using write the command for declare the limit of dx, dy and dz like this, and using the triple integral command and set the limit of dx, dy and dz, and we can get the answer for volume of the question. The answer equal to 544 over 3 unit. That's all. Next, question 2b, cylindrical coordinate. In this problem, we calculate the volume of the solid bounded by z equal to r square, z equal to 1, and cylinder with r square less than 4 in the first and second octal. Choose the two cylindrical coordinate r 0 to 2, theta 0 to pi, z 1 to r square. The volume is equal like this. After solving step by step, the volume is 9 over 4 pi or about 7.07 unit cube. That's all.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin Sabubari. My number metric is DE230140. Now I want to continue this presentation with the simulation for question 2B. First of all, we write all the information that have in the question in the code for Maple. After that, we use implicit plot 3D and implicit plot to make the graph 3D and 2D. After that, we can know the limitation of dr, d theta and dz. The limitation of r is 1 to 2, d theta 0 to pi, z 1 to r square. After that, we insert the limitation in the solution and we can have the value for volume is 9 over 4 pi. Alright, now I want to continue this presentation with the calculation for question 2C. After that, we know the equation that I have in the equation is x square plus y square plus z square equal to 9 square. We know the x square plus y square plus z square is equal to rho square. So the rho value is 9. To find the phase limitation, we use z equal to square root x square plus y square, and we rearrange using the sphere system to find the phase. The phase is equal to pi over 4. After that, we draw the 3D and we know the limitation of the rho, theta and the phase. The limitation for rho is 0 until 9, the theta is 0 until pi over 2, and the phase 0 until pi over 4. Now we insert all the limitation in the formula, and we can get the value of volume is 111.8 unit per. That's all for me. Right, now I want to continue this presentation with the simulation for question 2C. First of all, we write all the question in the comment. After that, we draw the 3D design for sphere. After that, we draw the cone. After that, from the 3D design, we can identify the phase limitation, and it is 0 until 9. The theta is 0 until pi over 2, and the phase 0 until pi over 4. After that, we insert the limitation in the formula for find volume using triple integral using spherical system, like in the coding, and then kita run. Now we can get the value for the volume. That's all for me.